Hello, my name is Corentin Jabot. I'm a freelance developer. People have been telling me for a while that I should give a talk including Sai and Chris. And so today I want actually to talk to you about JavaScript because I know nothing about C++. So this is actually talk about JavaScript. If you have questions, please keep them to the end because I have a lot to get through. And so in JavaScript, there's this tool called npm, which means not package manager, but it actually means JavaScript package manager. And that means that if you have done any kind of JavaScript in the past 10 years, or if you have been on a website, or if you have used the website, you have used that tool, whether you know it or not. And so the way it works is that you ask it to fetch a package, and it will download the source of that package onto your computer, and you can use it in your project, right? And so, so this command will fetch a package called request. So if you look at this request package, it has a bunch of dependencies. And it has several depths of dependency. And in fact, there are over 1 million JavaScript packages that exist in the same universe. And people have been building tools that actually show you this universe. This is a really small part of that universe. The big white dot there is actually the request package, and it's big because lots of people depend on it. And we cannot talk about npm without talking about leftpad. And so leftpad was a package to add some padding to a string. And for a reason that is not really important, it was removed by its author. Because of that, internet broke. And of course, the JavaScript community learned some lessons that day, namely that they should not be able to remove package from the internet because people might depend on it, right? And they learned that they should pin their dependency, which means they should maybe keep a copy and know which version of which dependency they use. And we fixed internet. And so people started to get back on internet, and they started to have opinion. And so this was like some actual headlines that were on blog posts and newspaper and so forth, right? But mostly we made fun. Sorry, that didn't quite work. Anyway, in the C++ community, we were mostly amused. First off, it would never happen to us, right? And we also didn't really care because we were writing on this command line parser. It was the 10th that command line parser we wrote that week. And we know that leftpad is actually really easy to implement, right? If you look at this implementation, that's a rotate. But anyway, leftpad, what is it? It was made by maybe a junior developer, right? And they couldn't find something to do that. So they wrote this piece of code. And they found it useful. So they put it in a function. They give that function a name. They put that function in a file. They wrote tests for that function. And they shared that function that they found useful with other people to use. So I'm pretty sure that people actually still know how to program, right? And of course, that implementation was not perfect. It was modified many, many times. But how long would it take you to write that function in a way that is correct, tested, efficient, and reusable? Because doing that takes a few seconds with npm. So package manager, in essence, are a way to produce and share code in a way that is trivial, right? Not simple, not easy, not doable, but really trivial. And you really need it to be frictionless for people to use your code, right? And what you want to do is allow people to focus on the part of their programs they actually care about, and not force them to maybe write 10 JSON parser or whatever. And you need that to actually be able to build an ecosystem and make it easier for people to contribute to maybe other people's code. Of course, package manager have issue, right? And micro packages, like package with one function of one-liners, are absolutely inevitable. And if we get a sufficient powerful tool, this will happen and there's nothing you can do about it. So maybe as a community, we actually won't make it really hard to use other people's code because we are concerned that other people write bad code. But if we want to have dependency, we need to trust other people. So dependencies is mostly about trust, right? And the problem is that trust actually have to extend transitively to all the other dependencies that your direct dependency depend on, right? And maybe we are not super being, right? Maybe we just have bad tools. And so this is my talk, dependency management at the end of the rainbow. I need to explain that title. So dependency management at the end of the rainbow, because it's not a pragmatic talk. Most people are going in a specific direction. I'm going in the complete opposite direction. I'm taking the road less traveled. I have a unicorn. That will look nice. There is a rainbow. We'll see what happens. So you have to understand that this is not a pragmatic talk. And the idea is like try to see if we can make something like NPM, which is the JavaScript package manager, or Cargo, which is the Rust package manager, right? And basically every language do have package managers these days, except of course C++. A few years ago, Bjarne talked about this problem at CPPCon, and what we want is make it really easy for people to use package manager. And there was like some survey taken by the C++ Foundation, and what people want is like better way to deal with package management and libraries. So how can we do that, right? And so a few disclaimers, this is not a talk about code. I know nothing about code. You should watch other talk if you care about that. I really recommend you watch this one, which is a talk that Titus Winter gave at Pacific C++ about evolving C++ and how to write code at scale. And it is really interesting in the context of my talk. It is not a talk about tools either. If you want to learn about tools, you should watch a talk about CMake or a talk by Robert Kumaker about VC package, for example. So I basically have nothing to talk about, right? But there's pizza, so it's fine. So we have code, right? The idea if you have code is that you cannot assume that tools exist, right? Because people don't use tools, tools don't work, they are not reliable, right? And of course we have tools. And the idea of tools is that people are not willing to modify their code, so you have to support everything that was ever written in the last 60 years. And to make that work, we need, of course, the C++ compilation model, which is the mechanism that will transform code to executable, right? And all of that form the C++ ecosystem. And so unfortunately, we have to talk about absolutely everything, and I am way beyond. And dependency management is a glue, right? So we need to talk about everything. So what's a dependency? And maybe a dependency is a step. You need to build your program and you are glad to be there, right? This is what I want to tell you. But what's a C++ program? And it's not that like really complicated to define because there are many definitions. So some people would say that a program is like a collection of libraries. And maybe if you are like a loader and you try to load your program, you will find that a program is maybe a collection of symbols. So what is it? Let's ask the standard. So for the standard, a program is maybe a collection of translation units linked together, and the program has a text, and that text is distributed around source file and translation unit, and that's what a program is. So maybe it's a collection of translation units. Interestingly, libraries don't exist, right? The standard says absolutely nothing about library dynamics. That doesn't exist, that doesn't work. And so maybe we can start with a definition from the standard that program is translation unit linked together. We need to talk about header files, right? Header files are really simple. You just take the code in your header file, you copy paste in every source file that you have. There's absolutely no way that you can find bound in your header file because you can include like transitively many files. If you actually try to look at what's inside IOStream or vector, you find that there may be 50,000 lines of code. And so you cannot track anything. You cannot find in which source file is defined something you declared in another file. So you cannot really depend on either file. So you should not use either file. As I said, it's not a pragmatic talk. But fortunately, in C++20, we added a module to the standard. And module are translation units, right? And so maybe we can redefine a program as being a collection of modules linked together, right? And modules are bounded, right? They are like a begin and end. They're usually short, maybe 1,000 lines or so. They have a consistent interface across all your program, and you know in which source file is defined every declaration, so you can actually track your module, you get less ODR, and so you can depend on module, right? The standard will also say that translation units are a sequence of declaration, and some declaration are definition, and every definition shall be defined once. That's the ODR rule. And so what that means is that if you have that, does that work? That doesn't work. So here I'm trying to define a socket, but I also use that socket type from the Azure library. And so this is actually what I want to say, right? I want to depend on that socket class, right? So I have that socket from Azure, and it's in a namespace, and I need it to be in a namespace because I don't want my name to conflict with other people's names. And I have a module because, again, we live at the edge and everything is fantastic. And of course, that module needs to be in a file, and the file exists for people, right? We need to have a file because we need to write code in RD and so forth, right? But then we need to convert that to an object file, right? And what we usually do is we start to make libraries of all of that, and then maybe you have packages, all of that. And the problem with packages, they are black box. So you don't know anymore what's in them, right? And to make everything work, we need, of course, compilers, but we need also build system and meta build system and meta build system. And this is actually something that people do, right? And of course, if you have library, you need loaders, and we have package manager. And people actually do package managers. That are things that exist, right? So a program is all of that, right? It's library, it's symbol, it's translation unit, it's definition. We don't really know. But it's a dependency graph or something, or maybe it's a dependency graph of graph or graph, right? And the problem with graph is that they grow, and they grow really, really fast. So we need to keep our system simple, because if we have complexity in an individual branch, the tree gets unmanageable really, really quick, right? And so how can we keep things simple? So we need to talk about system-provided library. So that library that you install with apt-get or something like that, right? It's mostly a problem with Linux distribution, right? So you have like these maybe two systems, right? You have your system A, which is maybe your development machine, and you are trying to have a program and you want to ship that on system B. Are they the same system, right? You have like this library, are they the same? You don't know, it's a black box, they are compiled and you don't know what's in them. Are they compatible? What does compatible even mean, right? Because it's not something that you can really define in standard term. And like, if they have the same ABI, are they still compatible? Do they have the same semantic? You don't really know. Maybe the library that you're trying to use is actually malware, and you're loading that in your process, and so you are responsible for compromising the computer of the people that are running your code, right? And most importantly, you don't know how that system will evolve, right? If like the people you are shipping the code to is updating this computer, will your program still work? You don't know. So if you use a system-provided library, you get tied to the deployment platform. So you have to care about ABI, right? And basically what an ABI is a gentleman agreement to never change anything ever again, right? And so then you get tied to the platform compiler, and as a consequence of that, you leave at tail. So talking about ABIs, there was this talk 2 years ago from Jack McNellis, and he was talking about DLL for 1 hour, and he worked at Microsoft, so he knows better than anyone how DLL work on Windows. And when he was talking about exporting C++ ABI from DLL, that was his advice, right? Because Microsoft makes no guarantee whatsoever that it will work, and it in fact breaks every few years. So maybe you should not have a C++ ABI. And so what I want to tell you is that you should not use C++, you should use C. If you care about ABI, right? And if you don't want to use C, you need some kind of mechanism, maybe COM-dbus, some kind of IPC. And what you want to do is have a clear boundary between different parts of your program that are written in C++, and you want the smallest possible interface between the two that is really bounded, and you know what it is, and you don't like pass any C++ between the two, you don't pass any allocation, you don't pass anything whatsoever, right? But and the consequence of that is like share library may be useful, but you should not try to share them. Okay. So now if you have used the build system, what the build system does is try to configure your build, right? So it will find things on your system, and it will tell you that it found something that you asked, right? If you try to like search for boost thread, maybe it will find something. The problem with boost thread, what does that mean? What do you mean when you say I want boost thread, right? If you look at the documentation at boost thread, there are like maybe 20 options that you can combine. And so when you find boost thread, which one of these thousands of millions of configuration do you get? You don't know, right? CMake will find it for you, right? And I'm not even talking about version. If you look at what other systems do, right, they don't find for anything. They just know where they are. They don't know what they are, right? So maybe dependency is sharing a common understanding of what name is, right? When we mean boost thread, what do we mean? When we mean Linux, what does it mean? Because Linux doesn't exist, right? If you talk about the kernel, fine, but if you talk about Linux distribution, none is the same, right? Windows is somewhat something you can define because they try to maintain a C ABI for very long, but even then, maybe Windows 10 doesn't behave the same as Windows XP, so you cannot say your program works on Windows, maybe. And what can we do to make that better? Maybe we need to take control over the environment, right? Maybe we need to be the environment. How to do that? You should build the world from source. This is really hard. It's maybe a 10 years goal. So you need to build the world in consistent environment, right? If you do that, your life is fantastic. And then you can have source dependencies. And maybe you can be assertive about your dependency as long as you can have no conditional dependency, right? Instead of trying to say, okay, on this system there is libzip, I will use libzip, otherwise I will do something else. You can just say I depend on libzip, right? And the dependency manager will download that for you. Of course, there's like, there was this talk at CPP last year, and Robert Schumacher, who actually worked on package manager, told people don't have dependency, right? And what he meant is that if you don't need something, don't depend on it. And the other thing you really should try to avoid apt-get or whatever, or RPM or this kind of thing to do like development, right? And so you don't want to use the system package manager, but maybe you want to use something like VC package or Conan. And whatever you do, don't bundle your dependency, right? Ask me, I need you to get that for me. And until you get like a tool like NPM, you can like write in your README that you need that, and I will get that for you. And if you actually look at the code that we have been writing in like the past maybe 5 years or so, we actually already build things from source. And the reason we do that is that we have all these templates, these concepts, this generic programming that we really want to do, right? It's good practice. It's like modern C++. You should do that. And so if you try to like actually write modern C++, you will find that like, there's little that you need to put in implementation and in source file. But we still do that though. So why are we making our tool blind? Why are we using this shared library? Why are we using this build system that configure things for us and we don't know what they do? Maybe we don't have access to the source, right, for legal reason, legacy reason. And as I said, if that's your problem, you should really have a C ABI rather than a C++ ABI. Maybe we want to save memory, right? We want to have only one DLL loaded in memory, so we can save some memory at runtime. That was great in the 80s when memory was maybe $1,000 per megabyte. Now it's a cent per megabyte. We don't really care about memory. The only people who care about memory is people working on a embedded platform, and they don't have a loader, so they don't have dynamic library, and their life is fantastic. And maybe C++ is slow to compile, so all of that pain is because C++ is slow to compile, right? And it is, but we don't like to say it, right? We don't like to be invited to a meetup and say C++ is slow to compile, people get annoyed. So instead, what do we say? We say C++ has zero cost operation, right? And this is great, we like to say that, right? But it's the same thing, right? And this is what we want. We actually want C++ to do more at compile time, so it do less at runtime, and it's the essence of C++, right? So we want our compile time to be slow. But compile time do matter. Because if your program is slow to compile, people will forward declare other people's code. They will sacrifice performance and accuracy and correctness and everything just to compile faster. So how can we improve C++ compile time? Maybe we can buy better CPU, and CPU have been becoming more performant in the last few years. So you can actually buy better CPU for the same price. And now you can have like a consumer CPU with 32 threads. So you can buy better CPU. Maybe you can get better tool, right? And like last month, Microsoft said they improved their linker performances by a factor of 5, which is really impressive. And so we can actually improve our compiler, but there's a limit to what a compiler implementer can do, right? So this solution is just to do caching, right? When we have something that is slow, as engineer, what we do is we cache things. And we can cache transaction unit, right? On Linux, you can use Ccache. On Windows, there's like no good solution, so maybe Microsoft can find a way to do that. We can cache interfaces, and that is another reason why you should use modules. A few years ago, there was this project to cache template instantiation across instantiation unit, and you can get like, if you combine all of that, you can maybe get 10x performance improvement. We don't really know because nobody benchmarked modules yet at any kind of scale, but we assume if we do all of that, you can get better performance. Is that fast enough? Probably not. There's one trick to make C++ compile super fast, is just not compile anything, right? And if you don't compile something, it will compile fast. I am completely insane, right? So let's look at library. I don't want to like pick on Qt because Qt is great, but they have like this module they call Qt core. I mean, not component rather than module. And it's a shared library with more than 200 public class in it, right? And it does everything, right? It does JSON, XML, Unicode, everything. And when you use Qt, do you actually need everything? Probably not, right? So maybe you need to write small library, right? And you want your library to be logical unit rather than this big organizational thing, you put everything. So it's the same when you say like write small function, maybe you also need to say write small library that do only one thing and do it well. And you will find that is more reusable and composable, right? And that's one main problem with header-only library today, they do too much, right? So if we write small library, we don't have to compile as many library. And I like to say that don't pay for what you don't choose, right? And maybe you heard that somewhere else. But the problem is that now, instead of having like big libraries that we can compile, we have maybe thousands of them. And it's really annoying, right? So what do we do, right? And we are not trying to write library, we're actually trying to write program. So this is what we do today, right? We maybe like install something, maybe we will build Qt that will take maybe a day, and then we will build Boost that maybe take a day too, right? And before that, we need to build the build system of Boost and the build system of Qt because they all have a build system. And then we did open SSL, and like, I don't know if you, like people do actually download SSL over internet from like this random guy that does provide SSL binary. And maybe at the end, what we want to do is like this small function that does only one thing, right? So we spend like 2 days building something, and then we have like a 2 kilobyte executable that does only one thing. Maybe what we can do instead is just tell the program what it needs, and the program can find the small library that it depends, and we can inverse the control that way, right? And some build systems actually do that, right? A modern build system like B2, Cubes, can do that. You can make Conan and VC package actually build their dependency rather than building the dependency you need and then invoking your build. So we can do that, right? Okay, so now you have some small library, the program compile faster, and so we simplify your build system and everything is great, right? Except there's compiler flags. Don't use compiler flag. It's as simple as that, right? Just don't. Libraries should only have requirements and dependency, and these terms are basically interchangeable, right? So maybe you depend on C++17, or maybe you depend on somebody else's library. Everything else should not be in a build script, right? Because then you have too many things you need to resolve, your build system becomes really complicated, you run into the diamond problem in your life, you hate your life, right? So Conan has a system of options, so you don't have raw flag, but you can still configure something, and each library can resolve the set of flag, and if you ask the build system to do something reasonable, it will do it. Bazel, which is Google build system, will tell you you cannot have compiler flag of any kind on your library, because Bazel is the pitch for that is a scalable build system, and Google knows that if you have any kind of scale, you cannot use flag because that doesn't work, and you get into all kind of trouble, right? The place where you want to put a compiler your flag is in toolchain file, right? So you can do that with CMake, and basically every modern build system has a way to set toolchain file, and toolchain file is not something we ship with your project, it's something people that want to use their code have, right? And you can configure your compiler like that, right? And in your build system, you don't want to have any kind of global state. You don't want to try to detect the environment and say, okay, if I'm on Windows, I'm probably using MSVC, right? Because that's not right. Maybe I want to use Clang on Windows. Maybe I want to use MSVC on Linux. I have done that. Maybe I want to use something else, right? Something you cannot possibly think of. Don't try to detect the environment. Just tell me what compiler you just have dependency and don't try to do anything else, right? Try not avoid negative requirement. If you don't need exception, you can build with exception just fine, right? Try not to set F no exception, because then people that try to use that library will crash if they call your code or whatever. And the question you have to ask yourself for every kind of flag is it a property of the tool or is it a property of the code? And everything else you can probably express in C++ code. So for example, warnings are property of the tool, right? They're not property of the code. Every kind of sanitizer, debugging option, you are trying to build a library with a debugging compiler rather than building a library in debug mode, right? So you can put everything in toolchain file, basically. And the big problem with compiler flag and conditional dependency and so forth is that everything can be observed from the code. And that brings an interesting question, right? How many program is there on that slide? Okay, maybe there is one, right? Maybe that's not a valid program, I don't know, right? I'm not a compiler, I'm just a package manager. Maybe there is one, right? Okay, let me give you a clue. That's a Hubble deep field, that's 3,000 galaxies, right? So how many prime do you think there is on this slide? Anyone? So let's see. If you look at that file and you open the IO3 header, you find maybe at some point you will find an if-def with this variable. And at some other point you will find another if-def with another variable, and so on, and so on, and so on, and so on. So maybe there is 0 program, or maybe there is 2 program to the power of 550, right? And this is a lot larger than the number of the universe, right? And so what that means is that if you try to install a package with NPM with maybe the 200 dependency, you have a complex system. If you try to do an Hello or C++, you have a chaotic system. And can you test that code, right? Do you have 200, 2 to the power of 500 test case in your code, right? You probably don't, because they wouldn't complete before the death of the universe. And okay, so let's see. If you have that code, I don't know if you like watch, get Gregorian emotional code, otherwise you should, but like, let's say you have this code, right? And you have this commented line. Do you agree that you should remove that commented line because you don't know what it does, right? You'd never test it. Okay, what if you do that? Right, is it different? Okay, what if you do that? Do you have like a Commodore 64 to where you run your code? Probably not. What if you do that? Okay, maybe that's reasonable, right? But if you don't have a Linux machine, and that's maybe some pull request that someone did that you know that Linux on your CI does that work, you don't really know. I think I'm missing some slide. Anyway. So let's say, no, sorry. So let's say we have like a more complicated example, right? So I'm trying to open a file, and I will do something in debug, I will do something on Windows, and if I'm on Linux, I will do something different, right? I will try to call the right platform API, depending on the platform on. You may notice there is a typo on that slide. I'm sorry for that. I should try to fix it. Okay, so now I fix the typo in the definition and on Windows, but it's not fixed on debug because I'm not actually trying to debug something, and so ClonkTidy didn't see that. And I'm not on Linux, so ClonkTidy didn't see my code, and that's the code that the tool see, right, and the compiler see. And actually, like handle is macro, create file is macro, everything is macro, every constant on that slide is macro. And so portability in C++ is achieved by making compiler tool blind, right? So portable code is not portable, and system programming is not something you can do at any kind of scale because you cannot trust that your code will be compiled. Can we do better? There is this line in the standard that says that you need to define everything once, except if it's in a discarded statement, you don't have to define it, right? And a discarded statement is something that is inside constructor branch that evaluates to false, right? So maybe we can use if constructor to actually compile our program portably. That would be nice, right? But what kind of condition can we put there, right? Okay, so what if I create that file and I have this constructor variable, and maybe on Windows Win32 will be true, maybe on Unix POSIX will be true. This like it's slide code, so lot if missing, and maybe I want to put that in like a module and namespace because you should always do that. So now I can do that, right? I can do if constructor I'm on Windows, I call that Windows function, and otherwise I call this Linux function, right? The problem is like on Windows, like it will try to return a void star, and on Linux, the system called return an int. What can I do? It turns out that there's this thing called stud conditional in the standard, so you can actually do that. So if Win32 is true, it will evaluate to void star, otherwise it will be an int, right? So you can use that as your type, and now your code looks like that. But the problem is like your function open and create file need to be defined, right? And this create file only exists on Windows, and open exists only on Linux, right? So you need to redefine it, and maybe you want to put that in namespace because you tired of having like 5 letter function at global scope, right? So you put it in namespace, and you put it in module because you should always do that. Other problem, every constant in C++ is a define. Every constant in C is a define. So what can we do? So we need to dance around to like transform or define it to constructor variable, but we can do that, right? You will notice that this code is always defined whether I'm on Linux or Windows. And on Windows, I have like some bogus values because I need to initialize my constructor variable. But this code will compile and be available on every platform, right? And of course, I need to implement that function. And so what I do is that if I'm on Linux, I will call the system function. That's the implementation file of a module. I'm sorry, I assume that you know how module work, and at CPPCon there will be many talks. So if you don't know about modules, please go watch CPPCon talk about that, right? But the important point is that the open function is always defined, right? But it is always declared, but only defined on Linux, right? And so then I can do that, right? I can do the same thing on Windows, and then I can call my code. If with the concept yes, we could actually do that. This is not valid C++20. It used to be at some point in the past decade. Concept has like very complicated history. But you can do that, right? And this is portable code that will compile everywhere, except if you try to call the create file function when you are trying to compile on Linux, it will just be a linker error, right? But it will compile. And if you do that, like, it starts to look a lot like Rust, right? And this is how Rust does portability. So we can actually replace macro by something I like to call a scalable C, right? And scalable C would be like maybe C with modules and namespace and constructor and this thing, right? I'm not trying to reinvent the Linux or Windows API. I'm just trying to put them in a way that can use them at scale, right? A few days ago, someone pointed to me that in the C standard, if you have any kind of functions prefixed with C, with is or to, your program is UB, right? And so C is not really designed to be scaled. And so we need to write dependable interface, right, with module namespace. And we need to have a conditional dependency, so our code is visible on every platform. That way we can tool our code, we can index our code, we can do all of these things. And we can provide a single interface of what we want to do across all platform and environment, right? And if you have like platform-specific bit, you can push that in definition in implementation file, right? So try not to have any kind of macros in interface. It is really hard, right? But aspire to do that, right? When you can. It will be worth it. And maybe someday we can do a VC package install Windows 10 SDK, and maybe we can do it on Linux. Because there is no reason that shouldn't work, right? Because code is just code. So what's a dependency? Maybe it's an immutable set of definition with a name that always means the same thing everywhere all the time, right? That it doesn't depend on your platform you're trying to compile your code on. Maybe that's a dependency, right? And maybe a library is a collection of modules, and that library has a name, and that name never changes also, right? And my point is that we don't actually need package because we already have libraries, and if libraries are a collection of modules, we don't need more abstraction, we need less abstraction, right? Okay, this is a Rust package, right? This is a build system, this is a description. So you have 10 lines, right? And this build like a TLS library. If you look at this C++ equivalent, the C and C++ equivalent, which is OpenSSL, it's thousands of Perl scripts to do the same thing. So we don't need, like, we can actually write build scripts that are 10 lines long, right? And this is a goal we need to go towards. Okay, so we talk about JavaScript, we talk about build system. Now I want to talk about politics to be sure that I never get invited to a conference ever again. Okay, this is a picture of a tape which contained Unix 8, I think. So this was 95. So it was 1 year before, 1 year after C++, basically. Unix did support some kind of ARPANET SID 75, right? And that was made by maybe a few developers over like a few decades. And maybe it was like thousands of lines of C. And you could like build that on your machine, and they didn't care about like namespace and module and so forth because everything fit on that tape, right? So they didn't care about like being dependable or scalable. But that's a picture of the Google campus, right? And they have a few thousand developers, and they have a 250 million lines of code. Right? And it's not the same kind of scale, so they have different problems, and they have teams doing refactoring at scale, and they're probably the best in the industry doing that. Okay, if you zoom out, right, that's a picture of the NPM repository. There's 1 million packages, there's 10 million users, and there is 30 billion downloads of packages per day. And there's basically JavaScript developers all over the world, right? Probably even in Antarctica and so forth, right? So package managers are mono repository, right? And they need to be mono repository because we need to share a common understanding of names, right? And version. But we have 3 million or so C++ developers. How can we make them share the same code base? And you won't like the next slide, right? Because like C++ is a language that for very long has put on freedom above and everything else, right? But if you look at like Cargo and JavaScript and all these tools have rules, right? And maybe democracy, maybe dictatorship, I don't know, but C++ is more like an anarchy, right? So we don't like rules, but we need them. The rule number one is maybe use the tool, right? And it's not a tool, it's the tool. And even today, like we don't have a good solution for package management, but we have like maybe 10 bad solutions. And people don't like to use a single tool, right? It's not in our culture. We don't actually need to have one tool, but we need to have one language to describe our dependency and our build system, right? This is what we need. And if you actually look at what NPM is, right, it's like a client and like this package description format, and it's the server, and the client has been re-implemented many, many times by Facebook. Facebook has Yarn, and you can use Yarn. And there's all of these clients, so you can actually write the build system that you want, as long as you consume the same build script as everybody else. Interestingly, if you use Mason, and you have like simple CMake script, Mason will be able to understand CMake script, right? So we need to find a way to describe our build script in a way that multiple tools understand, right? And so in C++, that's translated to use VC packager, use Conan, and use CMake, right? I know CMake is CMake, but it's better to use like less than perfect tool than to have 10,000 tools, right? So please don't try to write your own artisanal build system because that doesn't work, right? And that make it very difficult for other people to use your code. Another rule that we may need is like we need to make sure that our names, whether it's the name of like our library or module or namespace or entity, are unique across the universe, right? So we need to use namespace. You need to use modules, and you need to have name for your modules that don't conflict with anybody else, right? If you have like 2 modules with the same name in your project, right? Even if imagine you have like 1,000 dependency and 2 of them share the same module name, your program cannot compile. So you need to like, for example, prefix every module name that you have with like the name of your company or your pseudonym or like your GitHub identifier or something that is reasonably unique, right? And then we need to respect boundaries and scope of project, right? There is this standard document, SD8, that you can find on ISO CPP, is what the standard library will do, and the thing you shouldn't do with the standard library. Like taking like the address of a function you own, or trying to like putting something in somebody else's namespace, trying to transform somebody else's library into modules. All of these things like don't work because they break API, right? So you shouldn't do that. Dependency management is really hard. Like every slide that I had is probably like 10 years worth of work for the community. But it's like not really a tool problem, right? It's more a code problem. We have a bunch of solutions we can do, right? We can keep doing what we have been doing for 30 years. Maybe say that it is good enough, right? Like, and keep suffering for 30 years more years, right? We can do that. We can decide we want to put every single library that is maybe useful in the standard. We can have like a graphic library in the standard. We can have library WebView, socket, and all these things in the standard. The community doesn't really scale very well, right? There are probably more good libraries and there are like committee people. We can of course rewrite everything in Rust. The problem with that is like trying to rewrite everything in Rust would probably cost trillions of dollars. Or maybe we can rewrite some of our tools, and maybe we can rewrite some of our code to remove macros to make sure that in namespace, in modules, and this kind of thing, right? And we can rewrite our build system. And the way we want to do that is rewrite our build system until our root script is maybe 5 lines long, right? But if we do all these things, right? If you manage to do that, which is incredibly difficult, and it takes like the entire community, like there's nothing you can do yourself, right? It's like basically like climate change. You can not solve climate change yourself. But if you try to do that like as a community, we can actually make it work over maybe a decade or two. And if we do all of these things, right, we get like reliable refactoring at scale where you can just run a tool on millions of projects and it maybe just work as long as there's like no semantic change, right? Maybe we can index all of our code, including like the code that is not designed for the same platform as the code indexer. Maybe we can do like static analysis at large scale, right? Maybe we can do like cross compilation for free, right? If you use toolchain file and you don't have style, you get cross compilation for free by default, right? Maybe we can get better IDE integration. Maybe we can have more library on Godball because they don't have to deal with this complicated build system that we have today, right? And so dependency management is really about writing dependable code. And this is all I have. Thank you. Questions?
I have an annoying request.
Yeah?
Can you go back to the slide where you had no raw compiler flags? Okay, I want to take a photo and put it on the internet for everyone.
There's a lot of that.
That's why I said it's annoying request. I think you went past the review. You probably know your slides better than me.
Oh yeah, I did get past it. Yeah. There.
There we go. Thumbs up. Give me a thumbs up. Thank you.
Other questions? Yeah?
Has anybody looked into like what if cargo could become a cross-language dependency?
Yeah, so as I said, like cargo could like if we could make cargo for like the tool is not like a hard problem. We can write if you take like a small team and you like decide to do like a thing like cargo in C++, you maybe like 3 to 6 months of work, right? But it will not work with an existing code, right? Because the code that we have is like just too complicated. There's like this crazy build system we don't understand. And this is like the difficult part, right? So, but yeah, we could take cargo and do something with it, probably.
Okay, so follow-up question. If we need to start enforcing these rules to be able to get to that situation, should we start actually enforcing them?
That will be really, really difficult, right? We should, but yeah, it's difficult to convince. I think like we are still at the like the thing like the first step towards solving a problem is like recognizing there is one, and I'm not sure that we are actually at that stage yet, right? Yeah.
I mean, it's a very good speech, and like a lot of things are really very true and very nice. When you build a large systems. And how do you? I mean, this has been tried before. People have been trying to like not force, but to motivate people, encourage people.
Yeah.
Why do you think former efforts failed?
Sorry.
Why do you think former efforts have failed? Say like.
I don't.
Bruce
Okay, so the question is why former efforts have failed? Because it's like it's really difficult to get like 2 million people to change, and the default state is to continue like falling forever, right? And as I said, it's like climate change, right? We have like the technology to solve that, and the same reason apply, right? It's because basically people think that somebody else will solve that for him, right? Or they will wait that somebody else solve it for them before solving it for themselves. So everybody wait for somebody else to start, right? And I think my effort will fail too, right? I don't have like, I'm not naive, but yeah.
So maybe I can try to answer this question. So what I think changed is, first of all, there's a strong push inside of the community to actually get something running at all, because we're looking at some stuff like Rust and JavaScript, all the other libraries, and basically before Rust, the answer was basically, well, C++ is complicated, all the systems programming stuff is complicated, this is like things are in the space. And with Rust showing that it can be easier, I think this has changed. Secondly, the tools we have right now, the most popular tools with our VC package and Conan, are a platform. They are pretty much agnostic on what you use. So VC package uses CMake scripts, but you can package anything else. Conan uses Python, but you can package anything else. You have an example in the docs on how to package Go libraries. So that's a change, because even if you tell people you switch to CMake, there are tons of libraries and code bases that don't use CMake, like Qt, for example. They're just beginning to switch to CMake. And right now, they want to use Qt from a package manager. Well, I have to somehow bind to CMake. And before that, we only had some platform-specific approaches like NuGet that were just broken by design from a C++ standpoint. And then in the Linux space, we already had the system package managers and people that explained about it. And then there was just Windows, and it was this weird thing, and maybe built for it.
So are you saying it's fixed? Are you suggesting it is fixed?
I would suggest that we have the tools now to fix that, and now we have this push inside the community that it needs to get all the libraries, which is something that fixes it.
Okay, that's contradicted to what he said. What he said is no longer tools.
So the thing is, like, what?
The culture change, that's one thing.
Yeah, the culture, maybe. So the thing is, like, VC package and Conan are really great at giving package to people today. So they are trying to be useful, unlike me, which is I'm not pragmatic. They are trying to be pragmatic. So they take the existing complexity and they put a nice ribbon over it, right? They put that in a nice gift and they give it to you, but you still have the same complexity underneath, and you still don't have the same understanding of your program, right? So.
I was going to say that Morris's comments weren't picked up on the microphone, so I was wondering if Corentin would mind repeating them.
It's a bit long to repeat.
A long period of silence.
Yeah.
Any other questions? It's not really a question. You go to slide 125. Read the thing at the bottom.
So it says that function name that starts with is or to are reserved for C. Yeah, and so if you use the function that starts with is in a C program, your program is UB, right? and they did that because they wanted to have the possibility to add a function in that header, and because they don't have namespace in C. The other thing that is funny, so when C was in the 60s and even in the 80s, most linker would have a limit to the number of characters they would support, and this is why all C functions have 4 or 5 characters, because the linker will not, the linker will just not work with more than 6 characters, whatever.
So really, what you're saying is virtually every program ever written.
Yeah, so my theory is that every program ever written is QB because of that, or is ill-formed NDR because you have a static library linked from dynamic library, and that is you have ODR is really hard to enforce, and I think nobody can actually do that outside of maybe a hello world. So I think all C++ programs ever written are basically ill-formed.